So we're now going to try to find the equation, or basically the equation of the slope of a tangent line for any point along a curve. As we found in the last video, or as leading up to this, using the limits to find the slope and then equation of any given point, we would have to go through that process every single time as the point given changed. So in this way, what we're going to do is be able to solve for, and I'll throw up the equation here that we're going to work with, for y if it is equal to the square root of x. So we don't know what the point is. We're not given a point. We're just told that for this equation, we want to know how we can quickly solve for the slope that will then allow us to find the equation at any point that we want on the curve that that square root of x will create. So in order to do that, we still walk through very similar steps. And what we'll do is we'll start with the first steps that we've learned so far, and we'll just say that for f of x, so for f of x, we know that that is, we're just changing y essentially. We're just saying that f of x is the square root of x. So if we were to draw this out, we could say that if this point is, that's the point given, we're just saying that that the output is going to be f at square root of x. So this is really all we're doing here. The next one is just going to be that for f of x plus that little bit we call h, essentially we need to place that into our function wherever x is. So wherever x is, we're going to place x plus h. So we're going to say x plus h, and it's going to be the square root of. So we have those two values. Using the difference quotient, what we can then do is set that up, and we will say that for the slope of tangent line, and we're going to say that as the limit of h, as it is approaching 0, we have the square root of x plus h minus square root of x. And that, of course, is divided by h. And as you can see, we have a problem immediately. If we tried to substitute 0 for h, we would be dividing by 0. What we need to do, and as the goal is in this case, we're trying to eliminate division by 0, which means that we are trying to eliminate the denominator h. So in order for us to do that, we need to look at different ways that we might be able to work with the numerator and create a way to eliminate that denominator h. So one of the ways that we have learned that we can manipulate this rational function is that we could multiply the numerator or denominator by the conjugate. And in this case, we need to use the numerator because the denominator wouldn't give us much to work with. So let's see what that does. So if we multiply by the square root of x plus h, and the conjugate means that we only change that value of negative to a positive. So we now have positive or plus square root of x, and we need to make this a perfect 1. So meaning anything over the same value is equal to 1. That way this function doesn't change. The value of this function does not change. So that means that we have to multiply the denominator by x plus h square root of x plus h plus the square root of x. Okay, so anytime that you are multiplying by the conjugate, anytime that you're multiplying by the conjugate of the numerator, go ahead and see what it looks like first as in the denominator. Just leave that alone, and I'll show you in a minute what I mean by that. So let's continue bringing down, because we have not substituted 0. We need to bring it down and still state that this is the limit of h as it's approaching 0. And we will then have in the denominator h multiplied by the square root of x plus h plus the square root of x. And that's what I mean by do not distribute the h, because you may find that you have to then factor that h back out. So it just takes extra steps. But the numerator, we will go ahead and we will go ahead and FOIL this. And in foiling a difference, we will find that first it is going to be, and I'll do this on the side so that you can see this, but this is just basic algebra. We're going to take x plus h, my square root of x, so square root of x plus h, minus the square root of x multiplied by the square root of x plus h plus the square root of x. And we're going to FOIL this. And we end up with a square root times a square root gives us whatever the value is, the radicand. So we end up with x plus h. And then we'll end up with x plus h multiplied by the square root of x. That would give us plus square root x times square root x plus h. But then you'll notice that when you do a conjugate, you're going to end up with that exact same term, but as a negative, and it will cancel out. So you'll end up with a negative x square root x times the square root of x plus h. And then we would end up with, and finally we would end up with negative square root x multiplied by the positive square root of x, which would give us just negative x. So these will be these will actually cancel out, and we will end up with simply x plus h minus x. So we can begin reducing now. We can see that a positive x minus x reduces to 0. We're left with a positive h, just h in the numerator. And since we have left this unfactored, we have an h here, and we can reduce that. That is not 0, but that is 1. So h over h is 1. So we now have as the limit of h is approaching 0, we now have 1 in the numerator over the square root of x plus h plus the square root of x. And now we're working with a limit that we learned early on in the class, where we can go ahead and try to substitute h with 0 and see what that gives us. So when we do that, we don't need to bring the limit down anymore, because we're not approaching 0 for h, we're actually substituting it. So now we end up with, and make a little more room, we will end up with 1 over the square root of x plus 0 plus the square root of x. And as you can see, x 0 plus anything is just going to be that value. So x plus 0 is just x. So we end up with 1 over the square root of x plus x. And another way to write that is any value that's the same plus another value. So there's 1 plus 1. So we can call that 1 over 2 times the square root of x. And that is our slope at any given point, x. What I mean by that is now that we have this formula, if we had the point 25, and let's just say 3, if we wanted to know what the equation for the slope of the tangent line was at that given point, we can now just plug in our x value into our slope formula that was created. So we would have 1 over 2 times the square root of 25, and that would give us 1 over 2 times 5, which would give us the slope of 1/10. Now that we know what the slope is, we could easily find the equation of the tangent line at that point, and we could say that y minus 3 is equal to the slope we found was 1/10 multiplied by x minus 25, and we could solve that down. So then we end up with 1/10 x, and we would have 25 is 5, and 5 goes in 10 2 times. So we'd have 5 seconds, so minus seconds, and then we would add 3 to both sides, plus 3. So then we would end up with 2 is 6, is 11 seconds. So we'd have y is equal to 1/10 x minus, and let's see here, so 5 seconds plus 6 seconds is actually just 1/2. Sorry about that. So we have 1/2. And that is our equation, and that's how fast you can find it once you have a generalized slope formula to work with. So I hope that helps. Thanks for watching.